We're looking at Gcse Physics Unit 1 Higher Tier from Ccea for 2016. And this video looks at question 4. In motor racing, the shape of the track includes long straight sections and sharp bends as shown in the diagram below. Racetracks also have safety features such as a gravel pit and a wall of tyres, both of which are also shown in the diagram below. The diagram shows a racing car on the semicircular bend. Name the force acting on an object to keep it moving in a circle. So that's just straight bookwork out of your notes. The force keeping something moving in a circle is called the centripetal force. Part 2. Explain carefully what provides the force, or this force, on the racing car. So remember, the car's driving around a bend, and how it interacts with its surroundings is through its contact between its tyres and the road. So in this case it would be friction providing centripetal force. On the diagram, draw an arrow to show the direction of the racing car's velocity on the bend and label it V. Okay, so velocity is the way it's heading, and we know that the direction of movement is like this. So at this particular point it's heading that way. So we need to just add that to the diagram. Part B. If the racing car slides off the track on this bend, it's important that the driver and car are brought safely to a stop. Write down the equation that links force, momentum change, and time. So that's just your statement of Newton's second law, that F is mv minus mu over t. So the top line is the change of momentum, the bottom line is the time taken. Compared to hitting a concrete wall, a collision with the tyre wall reduces the possibility of serious injury to the driver. Use the equation to explain why this is. So this is the idea that if we increase the time, the change of momentum happens over a longer time, and F becomes reduced as a result. So this is what we want to explain. That increasing the time makes the change of momentum take longer, and that basically causes the overall value of F to reduce. So just a statement along those lines. So the change of momentum happens over a longer time, F becomes less. Part 3. When the racing car reached the tyre wall, its velocity was 10 meters per second. The collision with the tyre wall brought the car to rest in 600 milliseconds. Calculate the average force acting on the car during the collision. The mass of the car is 700 kilograms. Okay, so this is using that equation and filling it in. So we've just got our statement of Newton's second law, that F is mv minus mu over t. And then we make a list of what we know here, that U is not, these values here that we know, U is not, V is not, U is 10, mass is 700, and T is 600 milliseconds. So we're just filling that equation in now. And so we've got 700 times 0, 700 times 10, and 600 times 10 to the minus 3, because milli is 10 to the minus 3, so 600 milliseconds. And that gives us 11,667 newtons. Explain why slowing down at the bend reduces the possibility of the racing car leaving the track. So this is down to centripetal force again. There's a maximum amount of friction available when you turn the corner. If you go too fast, then you need more centripetal force than what you've got available, and the car slides off the track at that point then. So slowing down reduces how much centripetal force is required from the friction with the road. Remember, the friction with the road is what's providing this, so slowing down means that you're less likely to exceed how much is available. Once you exceed the friction available, the car will just slide off the track. To reduce the possibility of racing cars sliding off the track at the bend, it was decided to change the radius of the bend. Part 5, how should the radius of the bend be changed? So the radius is a value. Anytime you're asked about something that has a number, you should be thinking about should it be increased or decreased. In this case, turning a more gentle curve would give you less pull on the car. So you would need less centripetal force if it was a more gentle curve, and that would be a curve with a bigger radius. So it needs to increase. And then the next part's just an explanation of that. So increasing the radius causes the required centripetal force to decrease. And that is that.